Hello my friends. Okay, past videos we already have how much the well is going to produce or the reservoir is going to put in the well according to the actions we're going to take, like frac job, whatever. We know the IPR according to the action. We know this red curve. We know the actions and the results. And we also know how we're going to exploit the well. We know the condition of the fluid that we're going to lift. It could be the viscosity, the API, the GOR, if we have sand production. If we have a PVT, we also know that. We know what kind of wells we're going to, in front of. We have an open hole well, or slant, or horizontal, vertical. We have dot legs. We have the cement quality. How do we shoot the well? We know if we have electricity, or we have options of gas compression. If we are offshore, onshore. So we are ready to produce the potential of the well. But for that we use a nodal node in the bottom, and we see when we eliminate or we don't install any lifting system that the well is not producing. You can see that the transportation curve and the IPR, they are not crossing. So we are ready to produce the rate that the team decided that we should produce. In this particular case, the rate was 9,000 barrels, somewhere there. So what do we know from the experience? That a high rated well doesn't mean that it's going to produce naturally. And a low producer, it doesn't mean that, a low producer can produce naturally, and it doesn't mean the rate is going to be too high if I install a gas, an artificial system. Okay, so when we see the type of well we are in front of, like if we have GOR, if we have GOR, we think of gas lift. If we have high rates, we can think of ESP. If we have viscous and sand, we can think about PCP. So we have the idea ready, but we're going to decide. Okay, so it's something just to tell you that the suppliers, we need to meet with suppliers when we decide which system we're going to install, and also know that in suppliers they have good experience in the systems. Okay, so if we have, depends on what we have, we decide the completion. If we don't have gas, water, sand producing, we can produce open hole. If we have sand, we can run a slaughter liner and gravel packet. We can also cement and shoot, depending on what we have. This is some completion that we have in Venezuela in the Lake of Maracaibo. We put the gas lift mandrels right here, and we also have the option to install the monobore configuration. We cement it, not too high the cement, because we need to maybe the gas lift out somewhere around here. So, but that's an option, a monobore. We also can produce with the pump, the ASP pump. We can produce commingle, and we can, because we have a white tool, we can run a PLT to see the production of each one of the sand, and we can report that to the minister, so we are legal, and we tell them how much each one is producing. If we don't want to produce a commingle, we can produce through the casing with a pump, and through the tubing with another pump, And also we have the horizontal wells. We can use an open hole, we'll use a frac point, we set the packers and we do the fracking. Or we can cement it and shoot it and frack it, also fracture the well. So the first thing we do normally is we have an idea which diameter of the tubing we're going to have, right? So we have the software does that for us. Okay, then we go through each one of the lifting system and see which one is the one that applies for our case. By the way, as we see the advantage and disadvantage of each one, we're going to see a video here which is these are old videos from Weatherford, so we are going to use these videos from Weatherford. We start with the sucker rod pumping. The sucker rod pumping, you know, it's a system very old. I think it was the first one when 1859 they discovered the oil in Pennsylvania. The first thing they used was a sucker rod. It was made of wood, but it was like this. So it's easy to analyze and design. It can stay the whole life of the well. Could be automated according to fluid levels. If the well is not producing much or the reservoir is not producing too much, I can force the unit to stop. And it's used in steam injection projects, but they don't like the gas because it gets blocked. The pump gets blocked. The friction can damage the rods, you know, if we have deviated wells. It used to be very huge units in surface, but now this is getting much better. Not recommended for populated areas for the same reason. And sand is not an friend for these units. And you know how it works. We already saw it in the video, okay? The progress cavity pumping system, you also use rods, but they don't go up and down. They rotate and they move a rotator in the stator, so they lift the fluids. So this is very low cost. It can handle solids and gas and viscous fluids. It's very low maintenance and low environmental impact, but it has some limitation about the rates and the depth. And some facts is, if we're going to use it in light oil, we need to make sure that there is compatibility with the elastomer, because the run life can be very low if they are not compatible, okay? And the same as sucker rod, if we have deviated wells, it can damage the rods and it can damage the tubing, right? Because of the movement, okay? Okay, so we go to the next one, which is a hydraulic lifting system. In the hydraulic, we pump from surface a power fluid. We pump a power fluid that could be the same fluid. Well, normally it's the same fluid from the well. It circulates, it separates the oil goes to the tank, and the power fluid goes back in the well, and it creates a suction. It creates a suction according to the geometry of the areas. It creates a suction. That's why we drop those little bitty nozzles and things. And the pump itself, it has areas in there that creates the pressure, the suctions. So it works okay in deviated wells. Depth is not a limitation. Very flexible to fracture wells. Handle solids, heavy oil, and gas. But it requires high HP in surface. We need skills, but again, the suppliers, they know very much about it. But we need to know to talk to them and discuss the details, okay? It requires not a very low flowing bottom hole flowing pressure. So if we need to go very low, maybe this won't work. And the pump efficiency is very low, 30%. This next one is what we call gas lift wells. So like I said before, if we have gas, compression is available. The well can be deep, low, shallow, or, you know, we should use gas lift, because gas lift, you know, it's a method that run lives are very high because everything is done with bore line. So we have in Venezuela, in the Lake of Maracaibo, wells 10, 20 years, and they don't need a rig, because whatever we do if we need to do something to the valve, we can just get them with wire line, we change them. And if we have a leak in the tubing, we already invented some tools so that we can seal them off, you know, things like that. So it's very low, and it's okay for deviated wells. They don't care about solids, gas, flexible to do frac jobs, stimulations, pressure surveys, cleaning. Limitation, it's not good for populated areas because you don't want high pressure gas lines when the houses need gas. We need gas and we need the compressors. It's not good for heavy or viscous oil. The plunger is a system that has a plunger that goes down in the tubing, and it's good to for gas wells when they start producing water, or they go across the dew point in the bottom of the well and they start producing condensate. We need to get those liquids out of the well so that the gas can be produced. And also when we have high GOR wells, a lot of gas and very low liquid, we use also plunger because we need the gas, we need the pressure, we need everything to lift the plunger and get the liquids out of the way. So if we have a well that is not producing very much, like intermittent gas lift, we use it to reduce the fallback. Because you know, when we use gas lift, part of the plug that we're lifting goes back. So the plunger is okay for those kind of cases. And depth is a limitation. It needs gas to move the plunger. And when we have a leak in the tubing, we might need a rig. But it's very low. It's very inexpensive installation and maintenance, and it's set to pressures that, you know, release the plunger to the bottom of the well. And according to the casing pressure and the pressure of the gas at the bottom, it pumps it to the surface, and it gets caught here. And then when the pressure again drops, it goes back to the well, to the bottom, and finally we have the electric submersible pumping, which is for high rates. Like we said before, this is very used nowadays in high rated wells, and also in not so high rate, because they have built pumps for you know, to make it flexible for everybody. So it's very expensive because of the cables and the pump and the gas systems, you know, everything there is very expensive. They don't like gas, you know. They can handle gas, but if it's not present, it's much better. They're very expensive. The cable costs limits economics because of the depth. We need high voltages, and the idea of the casing is also a limitation. So it can be automated. It is very good to automate the system. You can make them talk. So they doesn't have very much equipment in surface. We can use white tool, like I said, to stimulate, to clean the well, to make surveys, etc. So, and nowadays temperature is not a limitation. So, if we have high rated wells that, like the one in the example, we can use ESP because we're gonna lift 9,000 barrels, and it's much better to do it with ESP. By the way, all these videos belong to Weatherfall, and we are using it. So it's available, you know, it's on internet, whatever you wanna. If you wanna see them, I just wanted to put them here so that as we see the advantage and disadvantage of each one, we can see how they work. Okay, my friend. So I'll see you next time. Thanks for being there. See you. Thank you.